Hey, grade 9s. All right, let's do the next lesson in our circle geometry unit. Before we talk about anything new, today we're going to be talking about central angles, as you can see here. I just want to do a couple review things, okay? So we know that circles have 360 degrees, which means that a half circle or a semicircle has 180 degrees. Okay, vertical angles are congruent, and remember that congruent means have the same measure or is the same size. Okay, so that means that if I had a pair of vertical angles, this angle and this angle would be the same, and alternately, actually I can still use I'll change colors, and also this angle and this angle would be the same. Okay, so that means that's what this second point is saying. Linear pairs are supplementary. Okay, that means they add up to 180 degrees. And this is like a little bit new for some of you, depending on how much you remember from previous years. That symbol means a circle. Okay, you won't see that symbol very often, but I just wanted to have it in here for when it does come up. All right, so central angles is the topic of today's lesson. And a central angle is an angle whose vertex is at the center of the circle. Okay, so it just means that, like you see in this, let's try that color, this circle here, you can see that there's an angle here, right? And it is following this directive because it does have its vertex at the middle of the circle, right? So if I take that highlighter off, you can see that the vertex, I'm going to zoom in here, okay, that's where the angle is formed, it's right here at the center of the circle. Okay, so in the first example asks us to identify a central angle in the circle below. Now, most of you are going to look at this example and see this angle and then close it that way. But I want to remind you that you can have a reflex angle. Okay, remember that's an angle that's larger than 180 degrees going this way. Okay, so either is fine. I am going to do the first one because it will be what most people would have thought of first, I would say. Okay, so that's angle APB. Okay, and yes, it would be fine if you angled it the other way. Angled it? Oh my goodness, you guys, named it. Sorry. Crazy. Okay. So that's the angle. All right, so now to do with central angles, we have this thing called arcs, okay? So an arc is a part or like a portion of the circumference of a circle. And we can also call the arc the portion of the circle that connects the two arms of the arc, of the angle. So if you look back here on this example that we did, we talked about this angle that I've highlighted, and that that you could connect the arms of the angle that way. Okay, and so that portion, that green portion of the circle there, would be the arc. Okay, and we always choose the smaller portion unless otherwise indicated. Okay, so in this example you could pick here or you could pick that whole big part over there, but we're always going to pick the smaller part unless otherwise said, and we're going to talk about that a little bit lower in the lesson. Okay, and the important pieces here is that the measure of the central angle is the measure of the arc. Okay, so that means that if this theta here was 80 degrees, that's maybe the worst writing of my life. Let's try that again. 80, there we go, that's better, degrees. Then we would have this arc measuring 80 degrees, okay? And so that's a new thing in grade 9, that circles can have, like you can measure the circumference of the circle, like this part, in length, okay, by finding part of the circumference, but you can also measure it in degrees. Okay, so let's do this example. Determine the measure of each arc shown below. So here we can see that this angle is 104 degrees, and so then that means that the arc is also equal to 104 degrees. Now, notation-wise, how do you write an arc? Good question. You are going to just use the two letters that connect the like edges of the angle, if that makes sense, and then you're going to put this little symbol on top that looks kind of like an arc, and then you usually put an M in front of it to show the measure of this arc is 104. Okay, so that's the notation. And then here I made it very easy for you. Okay, you can already see that we know that the angle is 60 and the arc is 60. Okay, and that's a pattern we're going to see many times in this unit. Again, we're going to take the two arms that connect the part of the arc that connects the two arms of the angle, and we are going to use those two letters to make our statement. Okay, so the measure, M, of the arc that connects AB is equal to 60 degrees. Okay, all right. There are three types of arcs that we're going to look at in this unit. A major arc measures more than 180 degrees, and there'll be a slight difference when we name those arcs because we're actually going to use 3 letters instead of 2. A minor arc is just like the ones we just looked at, okay? So they measure less than 180 degrees, and we use 2 letters to name them, just like we showed. So let's do an example about that. Okay. So this is what I was talking about earlier. Just like a minute ago, I said that we're always going to pick the shorter connection between the arms of the angle unless otherwise indicated. Well, here's otherwise indicated, okay? If I ask you specifically for a major arc, then I'm indicating you can choose the long way around, okay? So remember that since a major arc measures more than 180 degrees, and if you will recall from your math lives that a circle, half circle, has 180 degrees, then we're saying that we want an arc that's larger than a half circle. Okay, so I'm just drawing this dashed line in to show 180 degrees, like half a circle. So we're looking for the arc that's larger than it, which is here. Okay, so, oops, my bad. Okay, so major arc is going to be this portion, like I just said, okay? And so in this case, we're going to use 3 letters to name it. So we're going to pick the 3 letters that are on it. So we can see A is one end of that arc, B is the other end of that arc, and C is somewhere in the middle. Now, we are going to put those letters in the order that we see them, okay? So I'm going to start with A, and then I'm going this way around the circle to C, and then keep going this way around the circle to B, okay? So I'm putting them in order that we see them. That's really important, okay? And then again, we're going to put that little, that's so messy. We're going to put that little like curved line on top that indicates the arc. Pardon me, my goodness, the arc. Okay, and then a minor arc, again, that's less than 180 degrees. So we're looking for something that's smaller than half a circle. So we can see that this arc is smaller than half a circle. And so a minor arc that we would name here is, again, remember just using 2 letters for a minor arc. So we're connecting A to B. So we would say AB. And in both cases, it would be fine if you named them the other way. Okay, so it's fine if you said BCA for the major arc and then BA for the minor arc. That's fine. Okay, they're both good. The third type of arc we're going to look at is a semicircle arc, and that's an arc that measures exactly 180 degrees. Okay, and to name a semicircle or arc, we're going to use also 3 letters. Okay, so in this case, I made your life really easy because we can only use 3 letters on one side of the circle. You can see that E goes to D and then to F, and that is half the circle. How do we know that it's half the circle? It's because we can see this diameter here, right? And that cuts a circle in half, okay? So we can say that arc EDF is a semicircle. Of course, again, same thing. If you said FDE, that's fine, okay? All right, identify 2 major arcs, 2 minor arcs, and 2 semicircles. Let's do this. So I'm going to make a little category here for major arcs, a little category here for minor arcs, and a category for, I can't spell, it's not good. There we go. Semicircles, okay? Okay, I will say that there are many options in this case, okay? So if you did this example, like maybe you paused the video and tried it before I did the example or something, and you don't have the same answers, that's okay. There's a lot of answers that would be correct in this case, okay? So the first thing I want to point out is we do have a couple diameters showing up in this circle, okay? We have a diameter here, and we have a diameter here. And those are important because that helps us to find what half the circle is, which we're going to need in order to figure out where is a semicircle, and then what's bigger than a semicircle to find a major arc, okay? So just going to keep that in mind. Now, let's do the semicircles first because we're already talking about them. So since this is a that cuts the circle in half, that's a diameter, then that means this is a semicircle and this is a semicircle. Okay, and so I'm going to choose that first semicircle as my first answer. So I'm going from R to S to T. Okay, so in order that they're going around the circle, I can write them. Okay, so arc RST, that's a semicircle. Now I could choose the other side of that circle if I wanted to. Okay, I could go R to Q to T, or you could say from R to U to T. That would be fine as well, okay? Just as long as we have like the start and the end of the arc included, those would be true. But I'm going to choose a different arc this time. Okay, I'm going to work with this diameter this time, and I'm going to choose this side of it. Again, see what I'm saying? There are a lot of examples or a lot of options for the answers here, so if you pick a different one than me, it's fine. With this one, again, you can see there are 4 letters going around the arc, but you only need 3 of them. And so as long as you pick the one that starts it and the one that ends it, and then you can just pick either of the ones that are in the middle. Okay, so as long as you have the start and the end and then one in the middle, you're fine. So I'm going to use Q as my other one, okay? So I'm going this way, S, Q, U, okay? Again, if you went the other way, that would be fine. Okay. Let's talk about some major arcs, okay? So we know, again, this is a diameter. So if we find any arc that is bigger than that, so bigger than this or bigger than this, then we're in shape here, okay? And so I can see that if I went from R and then to the end of the semicircle, that would be larger than the semicircle, right? So that gives me a major arc. And again, you need just 3 of the letters, so as long as you pick the one that starts it and the one that ends it, you can pick either of the ones in the middle. So I'm going to pick T, okay? So I'm going to go U, T, R, okay? And again, you could write it the opposite way, and you might have picked a different example entirely, okay? And another major arc that I'm going to pick, I'm looking here, and I see there's a diameter, so I want something that's larger than a diameter, okay? And I can see that if I went from, let's see. There are actually so many options, you guys. Okay, I am going to take this one. It's very, very big in this case, okay? And that is okay. But it's the only requirement is that it's larger than half the circle. So I'm going from the start here of R, at R, around through T, through U, through S, all the way to Q. So as long as I have R and Q and something in the middle, we're in good shape, okay? And I'm going to say S this time, okay? It doesn't matter, like we've been talking about. You can pick any of them that are in the middle, that's fine, okay? So R, S, Q. Major arc. Okay, last but not least, minor arc. These, I think most people find them a little bit, oh boy, easier. Sorry, hang on. Just trying to get these lines to all erase. There we go. These people usually find a little bit easier because they're just like small ones, so anything that's less than half a circle, and that's usually easy to identify, right? So like it's very clear that this here is less than half a circle. I'll use the highlighter so it's easier to see. Like this, right? That's less than half a circle, so there we go. There's already one. And remember that we just need to use 2 letters to name a minor arc, so SR or RS, same thing. And another one that you could pick is, let's do this one. Okay, again, you could have picked like a totally different one than me. That's also fine. They're all true. Okay, and there's lots of options. So if you have a question about an option that you picked that's not the same as mine, just message me. Okay, here we go. If angle ABC is equal to 80 degrees, what is the measure of N? Okay, we can see that ABC is right here. And we want to know what's N. Remember that the measure of an angle tells you what the measure of the arc is that goes between the arms of the angle or connects the arms of the angle, okay? Pardon me, so N is also equal to 80 degrees. That does not look like a degree symbol though. There we go, degrees, okay? All right. I made a typo here. I apologize. This is supposed to say 68 degrees, okay? That's what's written in the diagram. We can see that the angle is 68 degrees. So we want to figure out the measurement of a major arc and a minor arc. Okay, so right off the bat, we know that we have an arc here that has to be 68 degrees. And we know that that is no, that's a minor arc, pardon me, okay? And we know that because that's less than 180 degrees, okay? And then a major arc would be going the other way, like this, right? And I'm noticing here that my letter, there's supposed to be another letter on the edge of the circle. It's like right about here. It's supposed to be a W, okay? I'm sorry about that. I guess it just didn't save properly, my bad. Just add that in, okay? And the reason that I'm saying that is because if we're looking for a major arc, we need 3 letters to name it, okay? So I'm going to go X, W, Z. Okay, and then how do we know how big that is? Great question. We know how big it is by thinking about the fact that we know that a circle is equal to 360 degrees, and we are going to take away 68 degrees of that because this portion is 68 degrees. So that leaves us with, and I'm sure a bunch of you are reaching for your calculators right now. That is okay. You are at home. I can't stop that. Okay, so when we take 360, we subtract 68. There we go. That's the measurement of arc XWZ. Okay, find the measure of the following arcs using the diagram to the right. So we can see here that we have a 90-degree angle and 151 degrees. And because this is a diameter, that means this is also 90 degrees. Okay, so you can draw that in if you would like. Okay, so let's take a look. So HI is the arc here, and that's everything but the 290-degree angles and the 151. So we're taking the 360 degrees, we're going to subtract 151, we're going to subtract 90, we're going to subtract 90 to give us our answer. Okay, if I had more space, I would write this out like vertically, but I don't, so I apologize. Okay, so that leaves us with 29 degrees. Okay, GJ. This one is a little bit easier because we already have its measurement just given there, right? We can see that square means it's 90 degrees. GJI is going around most of the circle, and so we want to add up this section and this section, right? And that is 90 plus 151, okay? So yes, also, everybody who's wondering, you can put this in your calculator. I did just double check my mental math to make sure it was fine. And then last but not least, we have HGJ. Okay, so that goes HGJ. Okay, and that is exactly half of the circle. We can see that because of two things. We can see the 90-degree measurements there, and we can also see this diameter that's running through the middle of the circle, so we know it's exactly half the circle.